Transactions are critical to a database, and we'll talk more about transactions in a future lesson. But the whole idea of a transaction is that it's an atomic set of work. Atomic meaning all or nothing, meaning that if we go to update 1,000 rows, we're either going to get 1,000 rows updated or 0 rows updated. We're never going to see only 50 rows or 1 row or 999 rows updated. And that ability to have an atomic transaction is fundamental to being able to call SQL Server a database. Every transaction you do, whether it's the select or an update or an insert, every one of these DML or data manipulation language commands that we've done always happen inside of a transaction. But sometimes you need to have a larger transaction. You need to be able to say, here's 3 pieces of work, and all 3 pieces of work must happen or must not happen as one unit, a logical unit of work. To do that, we use begin transaction and commit transaction or rollback transaction, one or the other. So here's some sample code, and this doesn't hit one of the databases, it's just some sample code I put out here. We're going to say begin transaction, and then within the transaction, we're going to do 2 inserts into an account type table. We're moving $100 from one account to the other account, and both of these inserts must take place or nothing should take place. So the first insert is adding $100 to account 123. The second insert is inserting a minus 100 into account 456. And if only the first insert takes place and not the second, then the books won't balance. So it's critical here that we're able to say both of the inserts together constitute one logical unit of work. So the transaction begins with a begin tran, which is the short way of saying begin transaction, and the way you'll usually see it in code. And it ends with a commit tran, right at the end of the end try block. So if everything goes fine, we're going to open a transaction, start our try, do 2 inserts, and then commit that transaction. Everything works fine, the try is fine, we jump down to the end, we skip the catch block. If something goes wrong, we'll begin the transaction, begin the try. Let's say the first insert works fine, and the server has some kind of hiccup, there's some kind of problem, we can't insert the second one. What'll happen is the catch block will come in, it'll roll back that transaction, undoing anything in the transaction that has been done so far, raise an error that we had some kind of problem, it was not committed disk, and then end that catch. So, T-SQL programming, stored procedures, what we've done is we've taken the real core of SQL, the select, insert, update, delete, and we've wrapped procedural code around it so we can put those basic SQL commands inside of batches and inside of stored procedures and execute them with some more programmatic control. But I don't want you to make the mistake of thinking the heart of T-SQL is the grandfather way of doing if, or the way it does begin try, or the raise error, or the cursor, or any of those things. The real heart of T-SQL programming was the entire last part of select and joins and subqueries and insert, update, delete. All we did here was wrap some programmatic control around those powerful DML commands.